Hello, my name is Matthew Finlay, and this is Lab 2 on Charge Tapes Revisited. Getting to the actual introduction of our lab. The goal of this experiment was to apply a more advanced computational model that determined the extra charge present on a piece of tape. Below is some key assumptions like air resistance. And then for supplies, we used a Python simulation rather than the actual in-person experiment. And below is the results of our experiment, which were 7.23 times 10 to the negative 9 for lab 1, and then 4.0 times 10 to the negative 9 for lab 2, this lab. Here are some actual important principles we used in our experiment. Coulomb's law, electric field for a point, the electric field for a rod, force of gravity, which we used to actually make our FNet, force and electric field, superposition, and then knowing that line charge equals the same as the collection of point charges. And those are just our important principles we used in our experiment. All right, getting into the actual procedure of our lab. We began by making charged tapes, which was done by pulling a strip of tape off of the base piece and then noting the charge it carried. To test this, we compared how the tape interacted with both neutral objects and negatively charged ones, like the pen that was being rubbed. And then afterward, we carried out the main experiment to measure the strength of the tape's charge. To do this, as seen in the diagram above, we hanged one piece of U-tape above another, and then we moved the second piece of tape underneath it and set the distance to see whether the tape would rise or drop. So we basically had a set distance, and then we measured how much the middle of the tape was, and gave us our D value. So that was the procedure we actually ran in person. Uh, for this lab, we did a actual glow strip code, which was sort of like a simulation. So for our glow strip code, our initial conditions were that tape length equals 12 centimeters, our tape width equals 2 centimeters, the area was 24 centimeters, the tape mass was 0.12, our electron area is 1 times 10 to the negative 12, and then the electrons in the tape are 2.4 times 10 to the 18. And here are our actual calculations. This was for the previous lab. I'm just going to go over the code instead of actually going over this. This is the first part of our actual code that we used. Here on the left is our physical constants, the K constant, the gravitational constant, the mass for our tape, and then our Q from our previous experiment. And then here is is the E field equation I created. Here's passed in the vector for the charge particle, as well as the observation location that you're taking from, and using the magnitude and norm function and actually built into Python. We just plug that into the E field equation, which is like K times Q over mag squared of 10 then times R hat. And then below is the function that creates the line charge. This is just this. It's not actually one that we created. Here's the second part of our code. The top left was where we actually created the vectors for the top tape and the bottom tape. Then the E scale. To the right here is our function that created the electric force on the top tape due to the bottom tape, and the bottom left was the actual creating of the arrows for the electric force as well as the gravitational force, and then some print statements for our gravitational force and electric force. Here were the results from our experiment. The Q from lab 1 was 7.23 times 10 to the negative 9. The Q from lab 2 was 4.0 times 10 to the negative 9. And we believe the Q from lab 2 was a more accurate result because we believe that the line charge gives a higher level of precision than the point charge. All right, now getting into the assumptions and errors of our experiment. We could have had measurement errors, so just someone taking the wrong measurement by even just like a small bit. And then loss of charge, as we actually charged up the pieces of tape, we could have accidentally touched our hands, maybe the table. And then non-uniform charge distribution. The tapes weren't actually held perfectly parallel to each other like they should have been in an actual real experiment, but that could have been sources of error. All right, now getting into the discussion, what if we had modeled each of our tapes as a single point charge like in the previous lab? So this would yield similar results to what we got in that one. The line charge model that we did in this experiment yielded a result of 4.0 times 10 to the negative 9, and if we had just done what they asked in this question, we would have gotten the point charge model, which was 7.23 times 10 to the negative 9. Next, why do these estimates differ, and then which value is more likely to be closer to the real value and why? So the two estimates vary because modeling the charge as a single point versus a line provides different levels of precision. So by breaking the rod into smaller segments during the calculation, the charge model gives a more detailed result, making it more likely to actually reflect the real value itself.